guys. Today's lesson is direct linear variation. Now, it sounds pretty complicated, but it's not. So, as I said, this is a part 1. There will be a part 2 with some more questions in it. Direct variation is a linear equation. Okay, linear equation. Do you remember the linear equation that we've done? It's y equals mx plus c. But it doesn't have to be mx. So in here, what we got is y equals kx plus c. That's all. And k has to be non-zero, okay? Because if it's a 0, it's going to be flat, no gradient, okay? So let's have a look. Example. Now, Anne-Marie noticed that with a new car, she could drive a distance of 567 kilometers on a full tank of petrol, 42 liters. So her car can have a 42 liters. That's max. Okay, so it'll stop there. 42 is the maximum petrol she can have. And she also discovered the result is shown in the table below. All right, so this is the table. Now, when you see table and it's got this P and D, just make sure you put some X and Y next to it so that you know where the X-axis and Y-axis is going to be. Okay. When she graphed these values, Anne-Marie found a linear relationship. Okay, so all these, each two value is the points. Okay, so we got these points set up here. And when you put it together, you will get linear, straight line. That's all that means. Okay, straight line. That's it. Now, can you see that X and Y, the P is my x-axis. That's why it's got P here on an X, right? Normally. And the Y is the D. That's the D here. Okay, so make sure you know what to do with that. Okay, question was to find relationship, meaning just find the equation. To find the relationship, the equation or linear function must be of the form d equals mp plus c. Now, this is the same as mx plus c. Main thing is this m is your gradient and c is your y-intercept. Okay? Now, but the vertical intercept, which is y-intercept, which is the c, is 0. Okay? It's a 0 because when petrol is 0, the distance should be 0. So it's here, it says no petrol, no distance. So therefore, the linear function is d equals mp because the c here is 0. To find its equation, the linear function, first we need to find m, the gradient. You could use 2 points gradient if you want to. Okay, so remember the formula? We got y2 minus y1, x2 minus x1. Okay, or because now we have y equals mx, which is really in here is d equals mp. That's what we are looking for. So we are looking for m. But all you have to do here is just substitute one of the points. We have 1, 2, 3, 4, 5, 6 points. And I'm going to use just first point, 10 and 135. 135. So 10, 135. Now that's my P, that's my D. So 135 equals m times 10. And I'm going to just put 10m equals 135 because I want the m to be on my left. And then I divide by 10 on both sides. I will get m equals 13.5. Okay, therefore, my equation, my linear function equals d equals 13.5 p. because d equals 13.5p, the distance d is found by multiplying the amount of petrol p by a constant amount 13.5. That means every time you want to find the distance, you just have to times by the 13.5 times petrol. That's what that means. And this is an example of direct linear variation. And we can say that d varies directly as p, or that p is directly proportional to p. So summarize it. Direct linear variation, if y varies, changes as x changes. That's just, I think that's just quite straightforward, really. So, or it says y is directly proportional to x. That's exactly what it means. So it means just y changes as x changes. Okay, and that's y equals kx, and k is constant. It could be any number. And k is also called the constant of variation or constant of proportionality. Okay, so that's what it is. Now, this one comes a little bit later, but I'll put that in there so that it'll help us to do the steps to find the equation. To solve a linear variation problem, now first, huge amount of like step 1, 2, 3, it's just all about finding equation formula. That's all. And then step 4 is substituting all the values to answer the questions, whatever the question is. So let's have a look at the first step. Step is identify the two variables, say x and y. So before it was like a d and p, but we need to put it as an x, y, and form a variation equation, y equals kx. And step 2, substitute values for x and y. Remember, we picked the 1 point from the table and then substitute in an x and y to find the k. In this case, k is the gradient, right? To find the, before it was m. And step 3, rewrite the y equals kx using the value of k. So after you find the k, you just substitute in equation. That's all, the formula. And then step 4 is the substitute of value for x or y into y equals kx to solve the problem, whatever the question asking you. Now, you probably have a vague idea what is happening, but when we start doing the examples, it'll be clearer. Okay, so example 8. The mass M, capital M, in kilograms of a metal varies directly. Now, this is the key word here, directly, as its volume V in cubic centimeters. Now, anything with the word directly or proportionally, it gives you the idea of y equals kx. It's going to be. And another indication is this. When x equals 0, y equals 0, or v equals 0, m equals 0. Now that is also indicating a direct linear variation. Okay, that's this. Direct linear equation means y equals mx. Okay, so we got that 2 indications says it's y equals kx. Part A, graph the relationship between m and v. Now I'm going to put x and y here just for my understanding. And we know that if I have to sketch it, it's all going to be in the first quadrant because it's all positive. So the y is going to be my m, capital M. My x will be v. Okay, so that's my x-axis and y-axis. So I'm going to do first one here. Okay, so when we sketch something on the number plane, we need to think about scale. Okay, there will be questions about sketching graph. So I'm going to go with the x-axis and y-axis. Okay, so the thing that we need to do what was it? Which one is the x-axis and y-axis here? This was my y1. It's my m, big M, in kilograms, and this was my V in volume, cubic centimeters. Okay, so that's what we got. And then I'm going to go with a 0. Okay, so I've got how many points I have? 1, 2, 3, 4, 5, 6 points here. Okay, 6 points. So if you want to, you can put it in a point form if you want to. Now, guys, remember what are we going to do here is I'm looking at my x values here. The first one, the V. It goes 0, 48, 60, 80, 160, and 140. Now, what will be my scale? I don't want to go to 1, 2, 3, 4, 5, all the way to 140. That would be too much. And I don't want to go maybe 10. 10 is also too much. Like I said, 14 of them, 10, 20, 30. So I reckon it would be better if we go with a 20. Might be okay. Because 140, it'll be about 7. Okay, so I'm going to put here 20, 40, 60. So that's what I've got the scale for x-axis. Now, y-axis here, it goes to 0, 14.4, 18, 24, 34.8, and 42. So I don't want to go by 1 unit up. I don't want to do 2. But what if I do 5? If I do 5, the maximum would be if I go to 9, 4 9 to 45. So if I go to 5, it would be 5, 10. Okay, so I think that's okay. Now let's have a look at, let's point them, not in a great detail of it, but roughly 0 and 0. That goes here, right there at the beginning. Now, because it's 0, 0, that's why it's called direct linear variation. Remember, y equals kx, 0, 0. Now, 48 and 14.4. So 48, that's like a 50 here. 48 is just before that. And 14.4. Let's have a look. 14.4, roughly here. And then 60 goes to 18, roughly about there. And 80 goes to 24, just below there. And then 116 up to just before 120, I suppose, and 34.8, so maybe 35-ish, roughly just below there. 140 goes 42, roughly here. Okay, so if I do that and then I join them together, I will get something like this. Okay, that's much accurate. Okay, so that's what you're going to get. So make sure you use your ruler and have a plan about your scales on the x-axis and y-axis. In this case, x is a V and y is m. Now, second one, find the equation for m in terms of V. So what does that mean? It means just m equals kV. And you just have to find the k. Remember, we don't have constant because it's going to be 0, 0. That's what it means. Now, what I'm going to do is I'm just going to use the point. Okay. Now, first point was 0, 0. I am not going to use 0, 0 because everything will be 0 here. And second point is 48 and 4.4. You can use this one, but I don't like the decimal in there. So third one is a 60 and 18. Well, I like that one because there's no decimal. So I'm going to use that. So this is my V. That's my M. Remember? That's my Y and that's KX, if you put it that way. So I will have a look at that. M equals KV. V at 60 and 18. So I'll put 18 equals K, V is 60. And I like the K to be on my left. So I'm going to go 60K equals 18. And then I'm divided by 60 on both sides. So that means 60K over 60 equals 18 over 60. Therefore, my K equals 3 over 10. Or you can do 0.3 if you want. And my final equation then, M equals, I'm going to just use 0.3, it's easier for me, 0.3 V. Now, I chose the 0.3 because it just, okay, terminating decimal. But if it's like continuing forever or something, well, that's not good. So you can use a 3 over 10 then. 3 over 10 is more preferable because it's accurate. Okay. Okay, next one. This is exciting because now we need to find the mass M when V equals 212. Okay, so you really need to understand, digest the question very carefully. After you spend so much time on the finding equation, the formula, after that it's quite easy because they're just going to give you a value of M or value of V. You just substitute in, you just have to find the answer for that. So we know that M equals 0.3 V, or you could, if you want, you could do M, oops, capital M equals 3 over 10 V if you want. Okay, so M, I don't know, 0.3 times V is a 212. Okay, so put it in your calculator, you will get 63.6. Now don't forget the units, okay, kilograms. Okay, so that's my answer. All right, example 9. The stretch S in centimeters of a spring varies as the mass M, capital M, in kilograms of the load pulling it. So it's basically, it's like talking about something like that. A load of 24 kilograms causes the spring to stretch 15 centimeters. So it's stretched for 15 centimeters. So let's have a look at the questions. Part A. Find the variation equation relating S to M. That means S equals Km. That's all that it was. Okay. So how do I know it's S equals Km? Because if I didn't put anything on the spring, it would be 0. Isn't it? 0 kilograms. Nothing to measure, nothing to do. It didn't stretch. It's 0 stretching. So anything with the 0 concept, it's this. Okay. So let's have a look. What do we got here? The information we have. Let's have a look. A load of 24 kilograms causing stretching 15 centimeters. Now, what does that mean? So when the M is 25 kilograms, the stretch S is going to be 15 centimeters. That's what it means. So they're giving you the starter points here. Okay, starter points. So this, I'm going to use this, and then I have to substitute M equals 25, S equals 15 into S equals Km to find K. Okay, because all we need to find is K to have the formula. So S15, K and M was 25. So I'm going to change the 25, K equals 15. And I'm going to divide it by 25 on both sides. K equals 15 over 25, which is I'm wrong, isn't it? It's 24 here. So I'm going to have 0.5/8, or we can have 0.625. Doesn't really matter which one you do it. So therefore, my variation equation is S equals 5. I'm going to do a fraction now. 5/8 and capital M. That's what I've got. Okay. All right. Now, what is the stretch? If the M is 13. Okay. Now, that's pretty simple now, because all you need is just use the formula, isn't it? So S equals 5/8 capital M, and I'm just going to put S, I don't know, and it's a 13. Now put that in your calculator, you will just get 8.125. Okay, and I think it's a centimeters. It stretches. Part C. What is the mass? So this one will be M when S is 25. Okay, that's not too bad. So formula was S equals 5/8 M. And S we do know, 25 centimeters. 5/8 M we don't know. And I'm going to put it onto the left-hand side, equals 25. And I'm going to times by the reciprocal of 5/8, which is 8/5, to make whole thing into 1. So when I do 8 times 5 onto 5 times 8, it will get 1. So, and then 25 times 8/5, and I will get 40. Because, cancel 1, 5. 5 times 8 is 40. So therefore, it's 40 kilograms. D is something interesting question here. What is that limitation of this linear model? Something that it's not going to be right. Okay, if there is a problem, what will be the problem for this linear model? The obvious one is for a very heavy load, the spring will become permanently stretched, wouldn't it? So that it won't bounce it back to where it was. So whatever the next load, the stretch won't be accurate because it's already been stretched. Okay, so that's what it means. So that's a problem. That's a concern about this linear model. I'm just talking about like a practical side of it. Okay, that's all that is. All right, so that's all for today's lesson. Guys, this is the bonus section. Now, I'm going to compare 2 linear functions that we have done so far. 1, linear modeling. 2, linear variation. Now, as you can see from the equation, the formula, you can tell the difference, can you? Linear modeling has 1 extra term, whereas a linear variation doesn't have it. It's a 0 constant. Okay? Now, but both of them start to step 1 as finding its gradient. In here, it's M, and linear variation, it's K, but they're both gradient. Now, as you can see, both of them, linear modeling has 3 steps, whereas a linear variation has only 2 steps. Why? Because linear modeling has 2 unknown, M and C, whereas a linear variation, it's got only K. That's 1 step shorter. Let's have a look at step 1 for linear modeling. Now, we need to have 2 points to find the gradient M. That makes sense because you've got 2 unknown here, M and C. Okay, so you probably need to have 2 points to find the m first, and then you will use that m to find c using 1 point. It could be the same point A and B that you used in here. So for example, A and the first step could be x1, y1. B is x2, y2. So you can use the same points from step 1, but just one of them. So you can use A or B or completely different point and to find C. Okay, after you find the M and C, your equation will be completed, wouldn't it? So you need to rewrite the equation using M and C into y equals mx plus c and use that equation to solve linear modeling problems. Now let's have a look at the linear variation. Now, because it doesn't have constant part, which is also called vertical intercept or y-intercept or little c, it doesn't have it. So you don't really need to have 2 points. You just need to have 1 point because you only have one unknown. Okay, it's easier to remember this way. Now, with the linear modeling, you got 2 unknown, m and c, so you need to use 2 points. With the linear variation, you got only 1 unknown, which is k. You just need 1 point. Okay, so all you need to do is substitute that 1 point, let's say x1, y1, into y equals kx. Okay, so substitute into x and y, and then you find the k. Now, after you found k value, rewrite the equation just like a linear modeling and use that equation to solve linear variation problems. Okay, that's all. See ya. Bye.